Social Security. We know where you live.
Hey, I think we're live.
All right. Can I get started? Hello, hello. Testing, testing. Can you hear me? Fantastic. All right. Well, thank you, everyone. Really full room today. Thanks, everyone, for coming out. Super excited to see you all here. Today, we're going to talk about account abstraction, ERC 4337. Quick introduction. So my name is Andrew. I'll be one of your speakers today. Account abstraction is interesting to me because I have personally lost or have gotten stolen many wallets due to the limitations of EOAs and private keys. With account abstractions, yeah, if anyone knows how to crack a private key, I've got some 5e waiting for you. You can find me on X or Discord here. And with me is my fellow speaker, Christian.
Hey guys, I'm not in the stream, but I'm over here on the side. Oh, he's good. I'll be on camera later, but you can see what I look like. Hello. So I put here championing good crypto UX because I'm working at Superform and we're really big on improving the crappy user experience that typically exists in DeFi. And we're going to talk about that later, and it's really relevant to the discussion at hand. I will also say, Andrew, that our next speaker next week, he's talking about like compliance and things like that. He said actually that he can help you track your stolen funds, and we can even do that live on the the presentation if you wanted to.
I've also lost many airdrops. So these are the exploited wallets. These are not my lost ones. These are my exploited ones.
All right,
Cool.
That's us.
Yeah, so that's your speakers. So I'll start by just citing some of the source material for this presentation. Main acknowledgements go to the ERC 4337 YouTube channel. Yes, I have one. A lot of good information there. And then there's a video from Devton Bogota, I think 2 years ago. Really good information there too. Highly recommend you guys go check those out if you want to continue your account abstraction journey. So with that, let's get started. So here's our agenda for today. First, we'll hand it off to Christian. He'll start with a quick overview of accounts on Ethereum. Next, we'll talk about what is account abstraction and why we want it. Then I'll come back and speak and give you guys a deep dive into the ERC 4337 standard and look at the roadmap ahead for account abstraction. And at the end, Christian will close it out by coming back and talking about a real-world example using account abstraction. Feel free to ask any questions as they come up. All right.
I'm just gonna keep this mic. I kind of like it.
Sounds good.
All right. Okay, so we're gonna start by talking about accounts in Ethereum because we're doing account abstraction. So what exactly are we abstracting, right? So there's two types of accounts in Ethereum. First, what is an account? It's an entity on Ethereum. And it primarily does two things. It can hold and transfer tokens, and it can interact with smart contracts. And if you've ever, you're interacting with Ethereum, you're probably using an EOA or an externally owned account. This is controlled by a private key. What does ECDSA stand for? This elliptic curve. Yeah. Digital. Yeah. Well, I think you got it. Elliptic curve, digital signature. Yeah. Anyway. Algorithm. All right, we had it. Nice, good work, everybody. Essentially, like private key, to keep it simple, and it can sign transactions. And then we have the smart contract accounts, which are controlled by code, not by a private key, and these cannot sign transactions. They can do a bunch of stuff, but you need an EOA to kind of interact with the contract and to kind of kick it off, to have some input to make it then output whatever it's gonna do. And then again, you have been using an EOA when you're interacting with Ethereum. But there's some limitations of EOAs. The two primary ones we'll look at are bad security and bad UX. So an EOA, it's both a signer and an account bundled into one. We know like public and private key cryptography, where your address is derived from your public key. You sign transactions with the private key, and it's simple. Well, I mean, simple is relative, but it has some issues. So with the bad security, there's one single private key. If you lose that private key, you're screwed. You lose access to your account, You can't recover your funds. It's literally impossible, right? And then there's no like recovery process for keys built in. There's some solutions that exist to kind of try to rectify this, but as it stands, EOAs, you lose a private key, you lose your funds, you have to set up a new wallet, your money's gone, and we also have this issue of access control. So there's only like one single role within an EOA that kind of can do everything, right? Like if you have the private key, you can do anything with the funds in the account. You can spend them without limits. You can send them to anybody, anytime. There's no like multi-sig built in. There's no way to like say I need somebody else's permission to spend money or to set up spending limits and things like that. None of that exists by default within an EOA. Again, you have the private key, you can do anything, essentially. And then finally, eventually, in the reality of the future, the not too distant future, is that quantum computing is basically guaranteed to break current like public-private key cryptography that we use in crypto today. So nothing that Ethereum is like has in the end of the roadmap. They're going to build in quantum resistance. But as it stands today, if quantum computing existed in a certain capacity, like tomorrow, every wallet in Ethereum would be susceptible to just being drained, essentially. And then there's bad UX. So a couple things here we have is like gas. So you have to pay gas for every transaction in Ethereum. So you have to get gas. And I'm sure we've all done this where like you get USDC sent to your wallet, and now I can't spend the USDC because I have to get the gas. And then I just saw someone on Twitter complaining about this the other day. They're like, they were trying to help somebody get set up on their first time getting off of like Binance or Coinbase or something, and so they sent USDC to their wallet, to their EOA, and then they're like, hey, why can't I spend this? Oh, you need gas. Okay, so they sent Ethereum to their EOA from the centralized exchange, but they sent it on the wrong chain. Now it was on Ethereum instead of Arbitrum. So now I have to bridge it to the chain. Now I can actually spend it. And then they just like gave up and they said, okay, screw this, I'm done. So you have to have ETH. This is very painful for onboarding. Like I said, for a new user, like we're kind of used to it. Although if you saw me last week, I couldn't even figure out how Uniswap worked. So even for someone who works in the industry, the experience can be kind of difficult. And then there's this issue of privacy. So if you're kind of like doxing yourself in this sense, right? Like so, I get USDC and that comes from some source, and you can only track it from the source it came from. But now I can't spend it because I need gas. So I have to send gas from my doxed wallet or from my KYC centralized exchange account. And now I've essentially like ruined that privacy if I wanted to keep that, right? And then the second point here is there's no flexibility. So we can't batch transactions. There's only one transaction at a time. If I wanted to do like multiple actions together, I have to kind of do those sequentially. I have to, if I want to do a swap and then a bridge, I have to like sign two different transactions typically. Some apps are, starting to, you can bundle these things together, but generally, you're kind of doing things one thing at a time. And there's no automation. So say I wanted to do some kind of strategy like a DCA strategy. I wanted, every week I want to buy $1,000 of USDC with my ETH or something like that, whatever. You can't actually do that like with an EOA natively, right? You can give away your key to some like centralized service to do things on your behalf, but that's just, asking for trouble. So that's the problems with EOAs or externally owned accounts. And the solution that we're proposing, well, we're not proposing, but other people have proposed, and it's currently, on the process of being widely adopted, is account abstraction. So what is it, and why do we want it? Let's talk about that. We kind of touched on this earlier, but an EOA is all in one. It can do everything. If you have the private key, you have full access to the account. And what can it do? So there's authentication. So I have the key, and I am verifying that I own the account or that the signature on my account is valid. And then there's the authorization, right? So like, what can it? If I have the key, what can I do with the key? And with an EOA, it's everything. I can spend every single cent that's in the account. I can send it to anybody at any time. I can do anything. And then the EOA actually executes the transaction, so it verifies it has full authorization, and then can do again anything. It can execute, and then it pays the gas as well. So it's responsible for all those things. And with account abstraction, essentially, we're like breaking that up into these three components, which are the validation, which is the authentication, the authorization, and then the execution and the gas. It's split up into three, and we can customize this in different ways. So with we can set up multi-sigs. We can say you have to have 3 of 5 people sign off on a particular transaction before it executes. You can set up custom roles. So think like you can have some kind of different accounts. So some sort of some examples we were looking at was like some administrator account and then some like user account or something, and maybe one account has like full power over the funds in the wallet. Maybe other accounts have limited like spend limits. Maybe I can spend $1,000 a week or something like that. You can think how this might work in like a typical like Web2 organization, right? You're gonna have people who as an employee, you're gonna have access to some set of the company funds over a certain period of time, but you're not gonna have like unlimited access to the company's bank account. There's like controls in place. Maybe there's a certain person that has to like sign off on a transaction. So I can execute a transaction, but I can rather propose a transaction, but it actually won't execute until some other party signs off on that. So all of this can be like built in via account abstraction. The next piece is execution. So we can do more sophisticated things. Remember, the limitation in the EOA was kind of like one thing at a time. Rather, we can batch transactions together. So with like one single signature, we can do a bunch of things all at once, which might be. It could be like very advanced. It could be like we're going to talk later about like some looking at the case study of Superform, doing some sort of cross-chain action where I can send funds from 2 different chains to 1/3 chain with swapping and bridging and doing all these things together, and I can do that in one single transaction. And this is also the automation piece, so we can have those other things I was talking about, like a DCA strategy, or set some kind of like auto compounding strategy or something like that, where I want to like have a yield bearing product that I can get rewards from, then I can sell those rewards and then reinvest them in the strategy, things like that. All this can be set up. And then the final piece here we have is the gas abstraction. So you can have cases where you can sponsor gas. So you can actually submit a transaction and pay 0 gas because somebody else will pay it on your behalf, or you can pay for the gas in some other token. So instead of it having to be Ethereum, you can pay for the gas in like USDC. So in the example where I only had the USDC in my wallet, I don't actually need the Ethereum to submit the transaction. I can just pay with the USDC and somebody's like paying the gas fee on my behalf. Okay. Let's look at like these specific examples of what we can do with account abstraction. So this first one being recovery. Again, we talked about if you lose your private key in an EOA, you're basically screwed. So we can set up things like social recovery. So this can be like if you have it in place that if you lose your account, you can say, oh, I have like this group of like my 5 friends, and if 3 of my friends, come together, they can help me like restore that account. This is typical in like MPC, if you've heard of it. Like there's typically going to be, I'm going to like have myself as one of these parties, and then maybe it could be like a centralized entity, and then my friend or something, and then if these people come together, we can actually restore or like get my private key for my account without, in the case that I lose it. We can do even fancier things. For example, if your friends suck, you can have this delay mechanism built in. So if your friends suddenly try and recover your account, like they try to like screw you over, in that case where like your friends have the ability to restore your account, there can be some kind of like delay, and then you get maybe like a notification or something, and then you have like a week as the owner of this like social recovery mechanism to like approve and deny that. And so you can kind of see these things like are, we're talking in the world of like code and blockchain, like anything's possible when we start to like build on top of this idea of account abstraction. We also have a dead man switch. So what happens if you die, right? Today, and this has been lots of cases, or people who have at least pretended to die, and if you die and nobody else has access to your private key, your money goes with you, right? Whereas in the Web 2, whatever, TradFi world, there's these checks and balances in place that if you die, somebody can come in and like recover that money typically. So we can actually build a dead man switch with account abstraction. And then something like, say your account wasn't accessed in the past year, you then delegated some other entity or person, like a family member, to claim that money on your behalf. And so as long as you're active, like within that year period, that's not going to happen. That person's not going to get access to your account unless this 1 year period lapses. Then we have signature abstraction. So a few things we talked about already was like multi-sigs. So you need 3 of 5 people to sign off on a transaction. We can have other signature schemes. So in EOAs we have this single signature scheme that we have to use for all transactions. Rather now we can like sign with our phone. We can use like a mobile phone authentication to like sign a transaction. Or your fingerprint or Face ID or whatever it might be. And BLS aggregation, won't talk about that too much, but essentially you can like batch signatures together just to have like lower gas costs in general for signing transactions. And then we talked about this before, like quantum resistant signatures. We can have like basically to make Ethereum quantum proof, we're changing like the signatures themselves so that they can't be broken by quantum computers. So we have these quantum resistant signatures that we can now do with account abstraction. I talked about this on the previous slide, but we can have different roles that exist. Instead of an EOA having unlimited access to all the money with the private key, you can have these spending limits. You can have like, oh, this person has access to this account, but only $1,000 per day or whatever. You can have, again, these admin roles. You can have these like verification roles. One example was like a, I can't remember exactly, but like I actually already talked about it. Like so you can have some person who's like they have to sign off on a transaction, right? Like they don't have somebody else executes it and then it doesn't actually, or it proposes it and then it doesn't actually execute until somebody else has said, okay, this is okay. Or you can have a role that can't even execute transactions, some kind of like admin accounting role or something that like they review every transaction that like maybe comes out of an organization wallet or something. But they're not the ones going to like propose a transaction or try to do anything. It's just before something actually ever executes, that they're like a final check. Like, oh, every transaction that goes from this wallet, this person has to say, yes, this is okay, this makes sense, this is compliant, whatever. And this can be anything. You can sort of anything you can imagine that would make sense in an organization or any circumstance with these roles. Also, session keys. Like think you could like log in for like a particular period of time. You talk about like, session keys you're kind of like be familiar with, right? So you have some like blockchain game. You don't want to have to approve or sign every message. So you can like have like a limited time approval. If you've used like Hyperliquid, maybe they're doing something similar to this. I don't know exactly how it works, but like you sign one single transaction on Hyperliquid, and now you can do like infinite trading with gasless and not having to sign any message to execute every trade on Hyperliquid once you like signed in, right? So it's kind of like session key, right? Sign in one time, do everything within the context of whatever you set it up to be, right? Might not be like full access to the account. And then gas abstraction. We talked about this as well. Just to go over it again, you can sponsor the gas, so I can have someone pay the gas for me. So maybe an app I'm using wants to have some kind of free gas campaign or something, and now you don't have to pay gas for your transactions. To actually execute the transaction doesn't cost you anything. You don't have to have gas in your wallet. You can just do things, and then some other entity pays this for you, or they can set it up such that like you have to pay the gas, but you can pay in some other token. Doesn't have to be ETH. Then there's this privacy aspect where, again, just if you don't have to have gas, you don't have to like. It's not as easy to dox your wallet by sending gas to yourself to do things. And then cross-chain operations. So this is like, again, we need to have gas on every chain if we want to actually do things, right? So they're a lot easier if you have this gas abstraction, because if I send funds to another chain, I don't have gas on that chain. Now I have to get gas on that chain. And if we're doing many different chains, I need gas on every chain to do things. It's really annoying. So this helps with that as well. And then there's the batching and automation piece. So we can guarantee that transactions will execute with atomicity. So there's a lot of transactions that only make sense if they happen together in some like sequence, and you want to make sure that those all execute. And if they, and there's lots of cases where like if they don't, like it's just going to, you're just wasting gas because things are just going to fail. And then like batching, we talked about this before. Like you can have a bunch of transactions all bundled together in one single signature. I can make a bunch of things happen on chain. And then this automation piece, or time delays, or event-driven flows. So it can be something like if it can be like an if-then statement, like if ETH hits $5,000, I want to buy 2 ETH or whatever. But it'll only happen if it hits that price, and I can set something like that up to automatically execute without needing to like be there at the time and sign that transaction. So this can be, that's event driven, or it can be time driven. Like I was talking about the DCA, every week I want to buy $1,000 worth of Ethereum. I can set up these things with an account abstraction enabled situation. And one thing we'll note here is that so we're going to talk about ERC 4337, which is like the main Ethereum standard that kind of it enables account abstraction in a way. Like this was the thing that started like specify what this might look like, and sets like the system that actually lets us do these things. But the standard itself, 4337, none of those use cases are like built into it necessarily. We can just like, because this exists, we can build all this cool stuff on top of it. And some of that stuff is like, not necessarily in practice today, or people are working on it, but it's not really like standard. Like if you're using crypto blockchain today, like all that stuff you probably aren't interacting with on a daily basis. Like you're still probably you probably need gas, you're probably not batching your transactions. Some apps are starting to build this stuff in, but it's not really commonplace yet. But this is the standard that's enabling it. But the actual use cases that we talked about have to be built by the wallets and apps that are building on top of said standard. And with that, I'm going to pass it over to Andrew. That was like a high-level explanation of account abstraction. Now Andrew's going to do a deep dive of 4337. So some of the more technically inclined people might really enjoy this. Good luck, sir.
All right, thanks, Christian. That was awesome. Yeah. All right. Well, thanks for that great overview of like what we can do with account abstraction. Now let's kind of dive into the standard and take a look at it. So first, let's kind of see how we got here, right? So just a little bit of a history. Vitalik was kind of aware of these limitations of VOAs as early in, he was already thinking about solutions as early as 2015 when Ethereum was first launching. The first proposal he made to address this was in February of 2017 with EIP 86. This proposal included a lot of the kind of core ideas of abstracting out the signature and allowing users to create contract accounts. There's one-known entry point. The main issue here is that in the kind of proposal he made, it was possible for a malicious actor to like spam the network with kind of like bad transactions and kind of causing kind of a denial of service attack. So that was kind of scrapped. So they were kind of thinking about that. A couple years later, they came out with a much more comprehensive solution. So this was September 2020 that kind of addressed this denial of service attack thing. Unfortunately, around September of that time, the core devs were busy implementing the merge, and they didn't really have the resources to take on another protocol change. In addition, the community, now that like people have been talking about account abstraction, this idea for a little bit, there was kind of more new demands or more expectations about kind of the future, right? A lot more UX demands such as gas sponsorship and batch transactions that weren't included in the EIP 2938 back in 2020. So they spent another year kind of thinking about this problem. And in September 2021, they proposed the ERC 4337. This didn't require any protocol changes. It included all of the UX improvements that the community was demanding. And that's kind of where we are today. So what is ERC 4337? It's called account abstraction using alt mempool. So ERC 4337 offers first full account abstraction, right? So kind of Christian talked about the separation of the validation and the gas execution, or the gas payment and the execution. That is implemented as achieved by this standard. Next, they use a decentralized mempool. So kind of like they learned about the issues with the EIP 86, the original one. It could be kind of, kind of the network could be flooded. By using this alt mempool, this is the alt mempool, this decentralized mempool, they made this system both censorship resistant as well as DOS resistant as well. We'll kind of go into details about that in a little bit. There's a robust infrastructure. So the standard came out in 2021. We're kind of talking about it now, like 4 years later. What's going on? Well, at this time, there's actually, because there's essentially a new client, a new kind of validator, a new node that needs to be run that kind of, knows about these mempools, knows about account abstraction. They worked on creating client diversity. So there's currently 9 different implementations, at least, of this bundler client code. So that gives us kind of client diversity on day one, kind of like the client diversity that we're kind of working towards for Ethereum validators, on the Ethereum blockchain. And then lastly, no protocol changes. This can be adopted by any EVM chain immediately, which is why we can kind of start doing it today. So there's 6 main components to ERC 4337. The first 3 are smart contracts. So there's the account contract. This is a smart contract that's actually deployed on-chain, and this is what will be the user's wallet. This will have an address. This could hold tokens. That can do swaps, do interactions. That is the account contract. This is anyone can kind of build an account contract. Anyone can kind of deploy a new one. These are kind of created as needed. Then there's the entry point contract. This is a singleton that every single wallet, dApp, and bundler knows about. So there's only one of these that exists on chain. It's kind of canonical, kind of like how ENS has a canonical registry. There's a canonical entry point contract that's deployed on each chain. And finally, there's the paymaster contract. These are optional helper smart contracts that will agree to pay for gas and sponsor transactions. So these are the people that are actually paying for the gas. The next 3 components are off-chain components. So the first is a user operation. A user operation is a pseudo transaction. We call it a pseudo transaction because it contains all of the data of a real transaction. It has, a to address. It has call data, as gas, as a nonce, and all that stuff. However, there's also additional fields in the user operation for the bundler and this alt mempool kind of thing. So those are user operations. And then user operations, once they're constructed, they will be submitted to the user op mempool. So just like the Ethereum mempool, this is a decentralized, permissionless, peer-to-peer network where bundlers kind of are able to find and exchange user ops and build bundle operations and stuff like that. And then finally, there's bundlers. Bundlers are nodes of this user op mempool. They know about user operations, they look for user operations, and they kind of build bundles of transactions. These bundlers will then, take a bunch of user operations, bundle them up, and eventually those bundle transactions will actually be submitted to the Ethereum mempool as a real Ethereum transaction on-chain, etc. So let's kind of take a look at how these 6 components interact with each other. So let's start at the top. A user, I'm playing a game or I'm using a wallet, and I generate a user operation. And that thing kind of says what I want to do. I want to do a swap, for example. That user operation is then submitted into the user operation mempool. And then once it's in the mempool and it's kind of floating around, bundlers will go and collect user ops and build blocks out of them. The blocks are then submitted directly on chain as like a real transaction, as a real Ethereum block. And then the user ops are given to the entry point singleton smart contract. And then that singleton smart contract will then interact with the account contracts or the paymaster contracts as necessary for each user op that was submitted. So let's now look a bit closer at the off-chain components, so before it kind of goes on-chain. So this is the user op mempool, and the bundler. So we kind of start on the, let's see, get a laser pointer in here. Start on the top right here. So these are user wallets. You can think of these as like MetaMask or Rabby wallets that you use today. We're kind of assuming they're 4337 compliant, but these are kind of what the users are interacting with. So the users will kind of interact with their wallet or interact with the dApp, and it will create a user operation. That wallet or dApp will submit the user operation into this user op mempool, and it kind of sits around there waiting for a bundler to pick it up. So once it's in the mempool, the bundlers will kind of pick up user operations and package them together into this bundled transaction. So this bundled transaction is actually a real transaction. It's just like any call onto the blockchain. And inside that bundled transaction, as part of its call data, is these user operations that they bundled up. And then once they're submitted to the Ethereum block mempool, then they're kind of bundled up into Ethereum blocks, and then they're mined, and then the chain moves on.
Some questions on that part there.
Go for it.
Okay, so first of all, when does the wallet have to be like, what do you mean by 4337 compliant? Can't just like a regular EOA interact with some app that I press some button on the app and I sign something that is then going to create a user op that gets sent to the mempool?
Sure.
Like, why does the wallet need to be compliant?
So you're right. I guess in this case, the wallet does have to be compliant, but the app needs to be compliant, right? So ultimately, you need to create a user operation. Today, most wallets and I guess apps know how to create like regular transactions. Well, this is a new type of transaction called a user op. So I'm just using wallet, but yeah, it could be a dApp. So like, you could use my normal Rabby to sign a transaction in a dApp that's like 4337 compliant, and then that dApp will create the user operation and kind of go through the flow.
And is it one user operation per transaction from the wallet or like on the app, or can I send multiple user ops in one transaction? Like how many can I get in this mempool at one time?
I think it's like per, I'm not sure specifically, like because each user op contains the information of one transaction. So it has like one to address that is interacting with, right? So generally I think it's 1-to-1, but because it's kind of like, maybe you could do some kind of funky batching stuff in there. But generally, the way that I kind of think about it is the user operation represents kind of one action, and then the bundler is responsible for kind of putting those all together.
So say I wanted to do like, I wanted to bundle one swap transaction and one bridge transaction. Are you saying, so that's 2 user ops, or would that be one user op that combines both those actions into one transaction? I
think that would be 2 user operations, but they could be like sent together as like a pair, right? So you kind of say, maybe in the second user op, you can be like, hey, don't actually, this user op might know about the previous one. Say, hey, don't actually include me in any bundle unless the first one's also included.
Right. So then in one transaction, I could send 2 user ops then.
In one transaction.
Like I'm thinking I'm using a dApp, and the dApp is account abstraction enabled, and I press the button on the dApp, or I set up my transaction that's like, I want to swap this token and I want to send it to some other chain.
Yeah, well, you're not really creating transactions. You're creating user operations.
Yeah,
right?
but
you're signing.
Yeah, but see, each user like use a swap user op and a bridge user op, and then am I sending those to the mempool in one action, or is that 2 separate actions?
I'm not sure.
I think they have to be separate.
Get a mic. Get a mic. We can't hear you.
Where is it? Oh, it's right there. How convenient. I couldn't see it. I think that they have to be separate if they depend on a state update themselves.
I see.
Like there could be, imagine like, this is one thing that you want to batch is like airdrop, right? Or like you're splitting payment, you're mass sending. That does not, each individual action is not dependent on some kind of state update. Whereas what you're talking about is, it's like it has to hit something's balance first before you can bridge, and that would not, it probably would not be valid as a user op because it has like side effects and it's hard to price.
Actually, I do also think that like maybe the user op. I have to look at the standard again. I do think it only like because you're passing in the address and the call data, right? I think it's just one call data. Like you can't have multiple.
No,
an array of call data.
Not within one user op. But okay, we're gonna come back to you, Yoni, in a bit. I'll talk to you later.
Will, yeah. Well, we can look at the standard a little bit.
Yeah. Okay. And then how? Okay. So In one bundle transaction, that could be a user op from a bunch of different wallets.
That's
okay,
right.
so it's
Yep.
kind of arbitrary. Like a bunch of different user ops could all be bundled into one transaction
Yes.
from a bunch of different people. So it could be a bunch of arbitrary things that I'm
Yep.
asking it to do from a bunch of different people.
Sure.
And then these are all put into one transaction, and then
Yep.
those get put on chain, and then. And then in the bundle transaction, when it executes, how is it like doing all those things in one transaction?
So we'll kind
Or
of
is it just in one block, I guess?
Yeah. So when the entry point contract, right? So these bundle transactions kind of the bundler will collect a bunch of operations, and it's not quite arbitrary. They do some like local validation. They want to make sure they'll simulate it locally and make sure that like, hey, this transaction will actually succeed, or this user operation will succeed. And if it doesn't, then they'll kind of throw it away. Just kind of like how if you try and simulate a normal transaction and it like fails, it's like you're not going to put it in the mempool, right? Or if it is, it's like not going to be picked up by anyone.
So one sec, in the case where I sent 2 user ops into the mempool, one to swap, one to bridge from the same person, do those have to be in the same bundle transaction, or could 2 different bundlers pick that up in 2 different transactions? Would that work, or like how did they?
Yeah, I guess like because the approve has to happen first, right? So then maybe the one bundler picks up the approve, and it can like execute it, and then by the time the second bundler picks up the swap, they'll simulate it locally, and if that approve hasn't happened yet and they don't know about it, then the simulation is going to fail. But if it has happened on chain and like the state's good, then they can do it. But like more again, possibly is like one bundler will just pick up both of them and just like order them because it can only kind of go in one direction.
Right.
Right. So this like ensuring that each user operation is valid and can actually, not only can it like succeed on chain, but also the bundler gets kind of paid back the gas that they're paying to do these transactions. That's kind of like probably a lot of the work that they do. But ultimately, there is a list of user operations, and then this transaction is actually just a call to the entry point contract, right? So that entry point contract actually, as part of its call data, takes in a bunch of user ops. So it takes in like a list of user ops and it'll just kind of loop through them and do all the on-chain stuff one at a time. So it is like user ops are like, right, you kind of have like a bunch of transactions and you wrap it into one big transaction. That big transaction is signed by the bundler, given to the entry point contract, and the entry point contract opens it up, takes out each individual small like user operation transaction, and then executes it.
And so would each user op that gets sent to the entry point is a one transaction per user op?
Probably. It does sound like that.
Yes.
That's kind of where we're.
That's what that's what I'm getting, because I just looked at it and they have to not only be pre-verified that they're valid, they have very similar fields to like a regular transaction.
So
they also have they're executed, they're like simulated, and they have like post validation. So like cramming more things than you could normally do in a transaction into a single user op is not supported. I'm sure there's a way that you could try to
Technically could do that.
You could?
Yeah, I'm looking at
There might be some funky, right? There might be some funky stuff they do, but I think in
you
general
could,
we can.
You could try to do it, but like I think that they would do better to reject them and not verify it.
So I mean, like ultimately it depends on what you're trying to achieve.
one user op.
Because like this is ultimately, even if you have 6 user ops, they're all kind of being executed in one transaction. So like if you just care about it being in the same block, or you care about it like happening sequentially, you can have it as multiple operations, even though it's all one on-chain transaction. Or I guess you could maybe you do care that they're different transactions for whatever reason, right? But yeah, I think generally these user ops consider them as one transaction at a time. And yeah, please go on.
I've got a really.
I think you're good.
Hello, is it on? Yeah. Oh, I don't even. Okay, cool. Really dumb question. User wallets here, creating user operations. So just to understand sort of the basics here, the EOA inside of the wallet is still intact, and is it signing
Not
a user
necessarily.
operation?
There needs to be
There's
some
still-
signature. So it could be an
Okay.
email signature, it could be a phone signature, it could be a password, right? This
Okay.
idea of the user operation, it contains the signature that the on-chain wallet, in this like abstraction and this account abstraction, the
Right.
signature is no longer required to be an EOA signature. It could be any signature.
It could be something else.
Exactly.
Okay.
So the user wallet just uses whatever that user signature is. So maybe in this example, it could be both a EOA signature, but it could also be your email password, for example, right? And then you submit that as part of the user op.
Okay. All right. I think I get that. Thank
Yep.
you.
And then kind of just speak about EOAs, right? Since the bundler is the one that's creating this bundle transaction, the bundler is still the EOA, right? Like we haven't made a protocol change. All transactions still require an EOA to sign an EDCDSA, signature. The bundler is the one that is doing that, and they're essentially fronting the gas. But because of the way that the user operations are set up, they can be guaranteed that they'll make the gas back, whether it's from the user smart account or from a paymaster. They will be able to get their money back, right? So this is kind of how we abstract away the gas. From the user's perspective, I signed with email and password. I didn't pay for anything. But what actually happened is that the bundler is the one that's signing underneath the covers to actually put the transaction on chain. And then, maybe the paymaster, maybe this is the app or some DAO is like, hey, I'm going to refund the bundler the money that it paid to do the gas. And now the user thinks that it's free, even though on chain it's not, right? So from a user perspective, any signature doesn't necessarily pay for gas, but the bundler, because it's still creating a real transaction, is still paying for gas, but they will get paid back. And they can be certain of that because they're validating the user ops. Any other questions? Cool. So this is the off-chain thing. We kind of talked about, the dApp or the wallet and the user op and the mempool and how it kind of gets put on chain. So next, let's kind of see what happens when it's on chain. Let's look at the smart contracts. So, right, user operations, and then put in a mempool, bundler picks it up, and now they call the entry point contract. So this is the actual on-chain transactions happening. So when that happens, the entry point contract will essentially do two loops. It'll do a validation loop and an execution loop. And this is how we're getting the the separation of validation and authorization from the execution part, right? So the entry point contract will kind of go through each user op. So let's say there's a group of 3 user ops. We'll take the first one, and it'll call the appropriate smart account contract and call validate. Will this actually work? And then it'll get back, yes, it will, and maybe it'll do some gas stuff. And then it'll take the second operation, call the appropriate account contract there, validate, that's good. Take the third one, it's all good. And now it's validated all of them, so this validation will check the signature, whether it's like an EDCSA signature or a username password signature or a phone signature, whatever the smart account is set up to verify, to authenticate, and then it can check authorization roles. Hey, do you have the right permissions to do it? And then once all of the validation has happened, it'll then actually execute it in this execution loop. So it'll go and actually call execute with each of the user ops, and then it'll actually do the on-chain stuff that you'd expect, right? So, and then optionally, as part of this thing, if there's a paymaster, some other contract that's sponsoring gas, the entry point can call into the paymaster and kind of get some gas back. So that's kind of like the on-chain part. Any questions there?
Yeah. So when I submit a user op, am I also specifying the account contract that is being interacted with?
Yes.
Okay. And then do I have to have some sort of ownership over this account contract in order to include it in my user op?
Right. So that's part of this validation loop. So let's say you point to some account contract. So the entry point will say, hey, here's a user operation from Christian. He wants to do a swap. It's going to go to the account contract and says, hey, validate, can Christian with Christian's signature do the swap? If it's yours, probably. If it's not yours, they're like, hey, I don't know who this guy is. I'm going to block this attempt, block this validation, and your user op is no longer good.
I see. So one account contract could be used by multiple people potentially, but it's going to have some sort of logic that says this user op must have come from this person or.
So this is the kind of in your example where I'm a corporate and I can send money, but it needs to be approved by my boss, for example. So I'm Andrew, I can, sure, let's use it, right? So I want to pay $50 for dinner, so I put that in the user op, and then maybe your smart contract account says, hey, Andrew is allowed to propose this thing and kind of set it up. So it says, okay, Andrew, it's definitely Andrew. I validated Andrew's signature, and I see that he wants to do this 50, so I'm going to stage it. I'm going to take that money out. I'm going to lock it in Andrew's ready to be paid thing, but I'm not actually going to do anything. I'm just going to wait for the next, my boss to send another user op that says, okay, approve it. And then once it gets to that account, it'll say, okay, Andrew's boss has approved it. I see that it's Andrew's boss's signature. I see that Andrew has staged this money. Now that I've gotten that approval, I'm going to now execute and actually transfer the money. So that could be like now you have two different user signatures, each with a different role, all kind of interacting with the same account contract.
So if we took that example to the extreme where the business world's running on chain, you could think like one organization might have like maybe one single account contract that all the business logic is set up in.
Yeah. So just like a business bank account. So like one of the use cases, you kind of go to the extreme, you kind of have multiple different roles. So let's say you have like an employee who can just, maybe they have a $50 spending limit. Every day, $50. So if the employee sends a user op that says, hey, I want to spend $50 for lunch, it's bundled up, it puts here. Validation says, okay, this is the employee, and I see that he wants to spend $50. That should be good. Now let's execute it, $50 is good. If it's more than $50, the business, this is like, corporate contract, corporate treasury will be like, no, Andrew's not allowed to do 50. Maybe there's like, now like an auditor. The auditor is allowed to like look and block transactions, but they're not allowed to make transactions. So let's say I'm Andrew, I send the $50 here, and maybe there's like a 12-hour delay, right? So it's like, okay, I see Andrew wants to send $50, I'm gonna stage that, and in 12 hours, then it can be executed. But then the auditor can come in and say, hey, no, Andrew's not actually allowed to do that. They can send an operation that says, cancel Andrew's transaction. And goes here, goes to account contract, and now in this corporate treasury, you can say, oh, Andrew was trying to stage this $50 payment, but the auditor said no, so I'm going to cancel that, get back at $50, that's great, right? So essentially, like, because kind of like code can do anything, you can have multiple different signatures or multiple different users, entities on here, and they can have different roles and different spending limits. All of that is kind of like, you can kind of think about it and implement it in code. You can all kind of package it into this account contract, so the account can kind of be able to be very flexible and be very advanced in who or what or how can money be spent or things can be done.
Cool, yeah. Another basic question, just trying to understand some of this stuff here. So we got blue is off-chain, right? Green is on-chain?
Yes.
Very simply, who's operating the blue part? Who owns that infrastructure and is operating that infrastructure?
So
if it's off-chain.
It's decentralized in the same way that, like, I guess ideally the same way Ethereum is decentralized, right? Okay. So like anyone can spin up a bundler. Those are clients that you can just download and you can run. And as part of bundler, so because you are fronting the gas, in order to get your user op kind of, you can prioritize or what, you can make a bit of a fee. You can, get paid X% or whatever, right? So now there's incentive for you to run this bundler, right? So now you have nodes, and then because of just like how, nodes talk to each other, you can have this like mempool now. There's, they don't know about the transactions. As Andrew, I can submit a user operation to this RPC endpoint, which is just like a bundler RPC endpoint. And that is a user operation, and then it gets kind of like, communicated throughout the network, and that's kind of like the mempool that's kind of going on. And then any bundler can pick it up and go do stuff, right? So, I mean, because we're kind of early, there's probably like, Ethereum Foundation is probably like hosting the majority of this, and maybe some like big key players. But the idea is that this could be decentralized as much as Ethereum blockchain is. Anyone can spin up a bundler. And then also, the way that this works, as long as there is one bundler, as long as there's at least one node running the bundler soft client, then this whole thing can work. It'll be probably a little slow. You might drop some transactions. But as long as there's one person running a bundler client, then this whole off-chain infrastructure can exist.
Thank you.
Yeah. Okay, any more questions about? That's right. We're going to... All right, so now you kind of see the blocks. Let's.
Oh wait, I do have one comment.
All right.
When the bundler prevents you from doing something or like censors you, it becomes called the bungler.
Yeah, let's talk about censorship. That's kind of interesting. So kind of the same way that the way that mempools work, right? If you wanted to do a transaction that maybe is blocked in a certain jurisdiction. So let's say in America. So all the bundlers running clients in America will not let you send money to North Korea, for example. Well, like if because of the mempool, because of how these user ops are kind of like communicated across all networks, all bundlers in the world, even if it gets censored by the America bundler nodes, maybe someone in North Korea who's running the bundler client, because anyone can just run it and join the network, can pick up that user operation and kind of execute it. So that kind of solves the censorship kind of issue. And then we kind of talked about the DOS, like because it's a mempool, you can flood this with as many transactions as you want, but because the bundlers will do some local validation, and then it can then communicate to everyone else that, hey, this transaction is good or this transaction is bad, probably it's bad. So if you send 1,000 bad transactions, well, maybe one bundler gets taken down because it's just like seeing all, it's just kind of checking all these bad transactions. But it doesn't affect all the other nodes because the bundler can tell, hey, everyone, like this is a bad transaction, this is a bad transaction. Don't spend any resources checking it yourself. Just know to ignore it, right? So that's how they kind of resist the denial of service attack. As again, this is kind of how mempools and decentralized peer-to-peer networks work in general. All right, let's get a little deeper. Cool. So we're on chain now. Kind of here, bundler has called the entry point contract, and we're going to look at the flow here. So this entry point smart contract, and in this example, all right, so this example, what we're looking at is kind of this validation execution loop, right? I kind of mentioned there's two of these. We're going to see what that means. And in this example, there's kind of two user ops. There's user op from user A and user op from user B, and each one has its own, so a smart contract account wallet A, a smart contract account wallet 2, and this is that entry point, the one singleton entry point that everyone knows about. So the bundler has paid for gas with its EOA to call the entry point with, and it called handle ops with the list of user ops. In this case, there's two user ops. So the entry point will do the validation loop. It'll take the first user op from user A. It'll say, okay, this is user A's smart contract account, and I'm going to validate it. So it's called validate user op on account A. And in this case, the account is paying for gas, so account A is going to say, okay, cool, this looks good. I'm going to give some ETH to you to pay for gas. And then the entry point will say, okay, cool, there's the money that I need to essentially do all the transactions here. And then it'll do the same thing for your account B. It'll take the second user op from user B, call validate user op on account, smart account B, and then it'll take some ETH, or user B will send some ETH to the entry point because it's like, okay, that's a good operation. And then the entry point will do some accounting to deduct that. And now both user ops have been validated. The signatures are good, the roles are good, everything's good there. The wallets are happy. Now it'll actually do the execution phase. So it'll then go and loop through again, take the first user op, and then it'll.
Gas? Did I hear you right on
So so like in this case, deposit, we're talking about depositing ETH. Yes. So I think in theory it could be like any token, like potentially if you have it set up so that the bundler is willing to accept like ERC20s as gas payment, maybe the account A just sends USDC into the entry point, and then that gets deducted or taken away, and then taken from the gas and kind of sent over, right? But yeah, essentially deposit is just like taking ETH and getting it ready to be sent back to the bundler to pay for gas. So validation, everything's good. Now we're on execution. So now it takes user op A, and it calls execute, and then now it's an account A, and then it'll actually go off and let's say it's doing a swap. So now account A is a smart contract. It'll call the Uniswap contract, and it'll do a swap. The Uniswap says, okay, cool, it's coming from this account. It checks the tokens, blah, 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 everything's good. And then it'll say, hey, how much gas did I actually spend here? And it'll say, oh, maybe there was a bit left over, and if there is, I can refund the gas that was taken here back to account A. If not, then we're all good. And then they do the same thing with account B, right? They take user op from user B. It calls account B. Account B goes off and does whatever on-chain thing it needs to do. And then once it's done, the entry point will say, hey, like how much gas did I actually spend to do these operations? And then if there's any left over, we'll refund it back to account B. And any gas that it actually spent correctly will then be sent back to the EOA, back to the bundler to pay for the gas that they fronted. And now we have completed an operation. Any questions here? Okay, let's look at it again. This time with the paymaster. So in that example, for example, there's two accounts and they're both paying for their own gas. Now we're going to see what gas sponsorship looks like. So this is the idea where I'm using an dApp and I don't have any ETH, but this dApp, maybe it's like for the first 10 transactions that you do, 10 swaps that you do, I'm going to subsidize your gas for you. Maybe that's just like a thing that the dApp is offering for its onboarding experience. So I'm a user, I do a swap, I create that user operation, sends to the mempool, the bundler picks it up, and then it bundles it up, and now it's ready to call the entry point smart contract, calls handle ops with one user op, and it is the swap from user A. So same thing, validation. I take user op A, call validate, make sure it's all good. And then it says, okay, this user op is actually using a paymaster. So I'm going to call out to this paymaster. This is the exchange paymaster that the exchange has set up, and it knows how to pay for gas and says, hey, are you willing to pay for this gas? And if it is, the paymaster is going to be, yes, okay, it'll send some ETH over here. And then entry point will kind of take that ETH and be like, okay, thanks for paying for your gas. And then it'll execute. It'll call execute, and then execute will go off and do the swap. And after that completes, the entry point will then call back to the paymaster and say, hey, the operation completed, do any more accounting that you need to do. And if there's any gas left over, it'll refund the paymaster back from whatever gas they didn't use. And I'll take that gas that's spent, return it back to the bundler, and then everyone's happy. So this is the flow with the paymaster. Make sense? All good? Cool. Let's see if we can do a demo. So we found this yesterday, which is pretty cool. So what I'm hoping for is that I'm going to be able to claim an NFT without having any gas. And that would be really neat. I don't know if this will work because yesterday or earlier today when I tried it, I don't think there's any bundlers running. So like all of my user ops got dropped. But here you go. So this you can kind of imagine is just like any dApp. Maybe this is an exchange or whatever. I'm going to connect my wallet, and I'm going to choose social login. So here, I'm going to sign in my username and password. Sorry, not username and password, my Gmail account. So now I have signed into this dApp, and here it has given me this wallet. So these smart account wallets are deterministic. So based on the, however I identify myself on chain, it can kind of create the smart contract wallet. And if we kind of look at it, so this is Sepolia, base scan, hopefully. This is all on base blockchain testnet. So this is a non-existent address, right? It's an address, but there's no transaction, there's no tokens, it's never been seen. This is just like a non-existent address right now. Because again, the smart contract account hasn't been deployed. So my Google account has this smart account that this app knows about. So I'm going to go sponsor transactions, and I'm going to try and claim this NFT. So I click claim, and you kind of see I don't click on anything. If this was Rappi, I'd come up and I can sign a message because I still need to do some kind of signature validation. So maybe it could be, oh, it worked, nice, okay, cool. So what happened here was the staff was able to get a signature from my Google account. Went to Google and says, hey, give me maybe it's a JWT token, maybe whatever, maybe it's an OAuth token, who knows. To get some kind of signature proving that's me. And then it creates a user operation. And that user operation has hey, Andrew, using this signature, wants to claim an NFT, and the gas is going to be sponsored by this dApp. This dApp has gas sponsorship. Because, you can see here, this account, I don't have any gas, right? I've never gotten gas. Cool, so that worked. And now if we refresh here and kind of see what happens, cool. So we can see here, this is now a contract. This address that was previously empty is now a smart contract. So this is my smart contract account. So this now has, for example, probably needs to refresh here, right? It has an NFT. So this was that ERC 1155, that cat drop. My smart contract now owns an NFT, and that was great. Let's kind of look at what happened inside here. So about 1 minute ago, handle ops, right, was functioned by this guy on this guy. So we open this up. 4337. This looks like just an EOA, right? It's an address. It has some ETH. It's not a contract. This is the bundler. So this is the EOA of the bundler that actually called, see, it's just calling handle ops a bunch of times. It's collecting a bunch of user operations, and it's calling handle ops on the entry point. And this 575FF is the entry point smart contract. This is the well-known smart contract that everyone knows about, and then we're all handle object, right? So all that's happening is different bundlers here are calling handle ops on the entry point. So what happened was the signer, the bundler, called handle ops, and inside here, it created this address, AEB, which is the address for me. I guess as part of this flow, right? So in this section, right? If accounts don't exist, this account doesn't exist yet, the entry point will actually deploy the contract. It has a factory, smart account factory that it calls into with certain call data that it will like deploy a smart contract. So this account A is always guaranteed to be there once it gets to this validate user op stage. If it doesn't exist, which in my case, the entry point as part of the call to handle ops will actually deploy the initial smart contract. I guess there's some default implementation, which is very small that we're looking at. What happened, right? So here looks like internal transfer. So 5FF, this is the entry point. It actually refunded point lot of zeros 8 ETH. And the cost of this transaction was 007. So that means the bundler paid, I'm just going to skip the zeros, 0.7 ETH to call this transaction. And at the very end, the entry point actually refunded the bundler 0.8 ETH. So this is like, hey, you got your money back, and also just a little bit because you're doing, the world a good service. If we kind of look at the logs here, so what actually happened here? So the first thing that happened was admin update. So this signer, whatever this is, so this signer, this is me. This is my Google account. Somehow my Google account was codified to OX418, and this AEB is my contract, right? So it's saying, okay, cool. I am now the admin for this smart contract. And then 85E, this should be the factory, right? So this should be account factory. So right, my account didn't exist. The entry point was like, okay, there's no smart account here. I'm going to call this factory, help deploy this smart contract. Cool. A signer was added. So AE8, this was my Google account. Oh no, sorry. 418, my Google account was added as the signer to this AE8 AEB smart contract account that was just created. Okay, cool. And then it's initialized, great. Account created, great. So now I didn't have an account, I didn't have anything. I have any on-chain experience. I signed into Google, created a user op, and the entry point smart contract was able to create me a smart account, a default one, very small account deployed, great. Then, let's see, user operations sponsored. So token 0, I guess this is ETH, didn't pay for anything. Before execution, so there's a paymaster, right? So like this mint happened, someone had to pay back let's see if this is the paymaster. This is a contract, right? So singleton paymaster. So some guy deployed this paymaster, and this I guess is the contract that's paying on my behalf for minting the NFT. So great. They're saying, hey, the paymaster is saying, yes, I'm happy to sponsor this user operation. Here's the information that you need. It does this before validation. So this is the validation loop. It actually calls out to, here's the nonce of the operation. It succeeded. Here's the gas that was paid. Here's the actual gas that was used. So the remaining was refunded back to, I guess, the paymaster in this case. Here's some more accounting that said the same thing. And we're done. So now, just to kind of see this again. This is my contract, AEB, that's right, yes. So, right, like what we kind of saw there was I signed in with Google, could have signed in with any signature scheme. I got a account created for me. I was able to do an on-chain transaction, in this case it was a mint. Someone else sponsored my gas, and we kind of walked through then the user operation went to the entry point did a validation, entry point first created my smart account, then it did validation, then it did the execution, paymaster paid for the gas, bundler was refunded, everyone's happy, and now I did a sponsored account abstracted transaction.
Wow. Wow.
That was cool, right? That was pretty cool. I'm so glad that happened because what I did earlier today just spun for 2 minutes and then said user op dropped. Cool. So that was ERC 4337. Hope you had a great time on this. Let's just quickly cover what's ahead for account abstraction. So the next step, now that we have 4337 kind of out and working, is we want to give EOA. So everything that we saw today was great. I have a smart account, but like most people are still using EOAs. So how can we give EOAs a lot of the kind of benefits of account abstraction? So this is my laser pointer out here, EIP 7702. So this EIP is a protocol change. It is actually part of the Pectra upgrade that is upcoming, soon TM. And what it's allowing you to do is that for the context of one transaction, it will actually upgrade the EOA to a smart account. So kind of like, how maybe my smart account can do Google signature authorization. I can kind of upgrade my EOA to allow for Google signature authorization. I don't know why you would do that. But like, let's say I can do that just for one transaction. So this way you can get a lot of the benefits such as batching, and you can get subkeys, even you can use some gas sponsorship. Those are kind of like the benefits that EOAs can get, kind of a short-term phase, or a next short-term step. Then longer term, eventually at some point, we want to take all this, right now we have bundlers and an alt mempool. We want to take all this great stuff and actually bake it into the Ethereum blockchain protocol directly. So there is a proposal, RIP, this is Rollup Improvement Proposal, 7560. So essentially take 433 logic, make it into the L1. That is kind of in discussion. I think what they want actually right now is for rollups, like L2s, to first do this first. That's why it's an RIP. Starknet, interesting enough, has actually integrated account abstraction natively into their protocol. So like you can do full account abstraction protocol level on Starknet, which is pretty cool. But the reason it's an RIP is they want to take a lot of the, there's a lot of moving parts here. They want to have Arbitrum and Optimism kind of like try some of this out first. And once they kind of do all the learnings and make sure it's all good, then kind of like maybe bake it back into the Ethereum L1 at that point. And we have a lot of time there anyway. There is kind of this question of like, how do we convert EOAs to smart accounts that exist, right? Most people have EOAs today. They already have state, they have tokens, they have stuff. So how do we kind of migrate that to a smart account? Do we just kind of use 7702 and just make it forever? Do we do something else? That's kind of a thing to be just figured out before they kind of canonicalize account abstraction to the protocol. And then some areas of research. So currently a lot of dApps assume EOAs. They will, in their dApp, they will check if your code size is 0. So it's like, an EOA versus a smart contract. And they will check for the signature when you sign a message. Is it can I retrieve, like a private key? Is a private key signed message? Recover the public key and make sure that it's actually from the person, right? Unfortunately, that doesn't work for smart contracts. Smart contracts accounts have code size bigger than 0, and they can't do an EDCSA signature. There is this standard ERC 1271 that actually allows for smart contracts to sign messages. So like dApps should just start adopting that, and then we'll be happy, and then have them just stop assuming EOAs. Then there's also this like default implementation upgrade experience. I don't know exactly when I went through my flow and I Google signed in, I had a smart account. I don't know what functionality was in that like default smart account that was deployed for me. So the question that kind of open for research is like, what should that default implementation be? And then how can users kind of add more functionality, right? I can sign with Google, but I probably can't give Christian spending limits on the account that was just deployed, right? So, but if I want that, how do I kind of like not have to redeploy a new contract, right? There is a standard that is currently being adopted, ERC 7579, minimal modular smart accounts. It's trying to define what a default smart account is, how to build kind of modules for it that can kind of be like implemented, consumed by the user, and kind of add functionality, remove functionality as needed. So that's something it's pretty interesting. Yeah, and then cross-chain L2 support. So the other question is like, great, if I want to, for EOAs, they're great cross L2s, right? One private key works across all the different blockchains. How does this work in smart accounts, right? So one example is like you saw me, I had to do a user operation, a bundle of send transactions to deploy my smart account. How do I make sure that that same account is also deployed on Arbitrum and Optimism and all the L2s? There's a couple interesting ideas like, do I sign once and just replay that transaction on every single chain automatically and then kind of set it up there? That could be one option. The other idea is like a key store chain. They're thinking about building this new L2 that's essentially your key store. So like maybe all of your smart contract account is kind of on that thing, and all the like validation logic is there. And then whenever you're like trying to do some transaction, it'll like call into the L2, do the validation there, and then like, come back and do the transaction there. There's some interesting ideas kind of going on there. But the idea is like, as a user, I want to make sure that it's easy for me to kind of set up my accounts across different chains without having to sign 20 transactions. And also there's no way for me to get in a weird state where like, oh, I sent money to this address that hasn't actually been deployed yet. Well, like now what, right? Like, did something break there? So yeah, that's the future for account abstraction. And with that, I will pass it back to Christian for our last section of the talk, a case study. Yahoo!
Nice. Thanks, Andrew. That was amazing. I like to think that my thought-provoking questions really helped drive home the content, but
yes, thank you.
That was mostly you. Okay, so the reason I wanted to do this talk was because I'm building Superform, part of the Superform team, and our V2 especially is really utilizing account abstraction, really pushing account abstraction to its limits, I think, and like what type of protocol can we actually build if we utilize all this stuff that we talked about. But I had no fucking idea how it worked. So that's why I decided to actually do a presentation on this with Andrew so that I could actually learn how my own protocol works. I'm not a dev, so that maybe explains it. I'm the guy who does the tweets and goes to battle in the Discord and things like that. So Superform V1 was a few things. At the app level, it's this like on-chain earning platform. So it's like the easiest, best way to earn yield if you have crypto, essentially. I have crypto. I want to access the plethora of earning opportunities on-chain to earn interest on my crypto. And this kind of manifested in a few ways. One is this like multi-chain yield aggregator. So there's like 1,000+ different earning opportunities across 10 different blockchains that you can access. And this is via chain abstraction. So we built a protocol that can access any of these earning opportunities on any chain, from any chain, using any token in one transaction. This was done kind of in a looking back, not to insult the brilliant devs I work with, in a bit of a clunky way, not utilizing a lot of this, account abstraction stuff with these, because these standards didn't really exist or weren't really in a state where we could build on them when Superform V1 was started to be designed, like, over 2 years ago, right? So V2 is kind of taking the learnings of that, and how can we take this, ultimately we want to build this seamless UX abstracted experience for how can I earn on-chain. So it's not live yet, still in development. It's actually in audit right now. It's scheduled to come out in about 2 months. So I don't have a demo or anything, but I just wanted to talk about it because it implements and builds on a lot of this stuff as well. So what is Superform V2? I like to say account abstraction in action. We don't call it that, but for the sake of the presentation, we will. So it's a unified application for on-chain earn products and strategies. Simply, it's like just the best and easiest way, again, to earn on your crypto. Simple. We wanted to create, like, if you've used something like, Robinhood or Wealthsimple, like, these super simple, good UX, accessible applications for accessing the world of finance. Like, we wanted to build that for the on-chain world. So there's two kind of main advancements in V1 over V2 over V1. There's a lot of things, but we can boil it down to this for the sake of this presentation, is Superform accounts, which are specific Superform design smart accounts for advanced operations, and then the Super Bundler. So this is our own, we talked about bundlers, this is our own Superform special bundler that uses hook-based bundling and execution to streamline complex actions across chains. Hooks we can just think of as when we were talking about like this, like the 7579 like modular smart accounts. The hooks are these like modules, these different actions that we can put and make a smart account execute. So breaking these two components down a little further, we have the Superform account. And so users interact with Superform through, again, this where it's built on this 7579 modular smart account standard. And what does that mean? Again, we have this standardized way for like, we're trying to build smart accounts. We're trying to introduce the world of smart accounts and have these more widely used in crypto. What should a smart account at the most basic level be, so that we have some sort of standardization? Like, ERC20, a token can be, a billion different types of tokens, but at their essence, they're all the same and they all interact and they're all interoperable. So we want the same thing for smart accounts. And so Superform is built on that standard. That's all. And what does that enable? All that stuff we talked about: batching, gas abstraction, flexibility, and more security. And then the Super Bundler, with Super Bundler, and this is where I wanted to, in a sec here, pull Yoni back in, because what the Super Bundler can actually do is in one signature trigger unlimited actions across multiple chains. And I don't exactly know fully how it does it, so maybe we can try to figure it out. I was trying to hash it out with Andrew yesterday. We have also chain agnostic assets and unified balances. So right now and today, I have USDC and Arbitrum, USDC and Optimism, USDC and Ethereum, and these are all separate balances. With Super Bundler and Superform V2, we can actually have all of those balances unified. I just have USDC, and I can spend it from any chain. I can spend it from multiple chains in one transaction. And then going back to this idea of like hooks, we have like these actions, and these are these smart instructions that can automatically execute before or after our primary transaction. Hooks and modules, and these being the building blocks of a transaction that a smart account would execute. And also when we're talking again about these like time-based or event-based things like a DCA strategy or an auto strategy, all of this can be set up through the smart account and the Super Bundler. And then diving a bit more into the Superform account itself. So there's actually going to be three ways to access Superform V2. One is via the smart account itself, which is this non-custodial wallet. It's a smart wallet embedded within the Superform app itself. So you're not going to have like Rabby or MetaMask, whatever. And then you're going to be able to access it just like you saw that Cat app. You can access it via Google, Apple ID, your email, any sort of login. I think some of the options were like your Spotify login or something you can like use. And then it's secured by passkeys, so Face ID, Touch ID, could be a physical key, whatever. Standard hardware wallet. And then you can access it from any device. So you'll be able to switch seamlessly between desktop and mobile. We'll obviously signing abstraction. There's no need to manage a password, no need to manage a private key. All that's abstracted away. And then again, the automation of auto compounding, DCA, all these things that we can automate. Alternatively, if you don't want to use a Superform account, you can import, because we're building on this 7579 standard, you can import another conformant smart account from some other application, because lots of other apps are starting to build on 7579. Safe is one example that you might be familiar with. So if you theoretically have a Safe account already, you can import that and use that in Superform in the same way. And then Andrew just talked about 7702. So if I have an EOA and I want to keep using that for my crypto stuff, I don't actually have to use a smart account that comes with Superform. You can use 7702 pending Pectra going live, and I can have the majority of this functionality with my EOA in that context of like one single transaction, like Andrew said. And then just a few more things, like specifically, like what can we do with the Superform account? So like we said, we can sign in across different devices with Google, Apple, email, you name it. We'll have fiat onboarding, so you can instantly fund your account. You can go from, I have my bank account, cash, Canadian dollars. I can go from Coinbase, Apple Pay, straight to depositing into some earning opportunity on chain, all in one transaction. And then, we have, no need for passwords. Everything is modern authentication, Touch ID, Face ID, a mobile first experience eventually, not at launch, but there will be a mobile app you just download on your phone just from the App Store, where you can access everything. Typically today, it's mostly through like desktop apps or shitty mobile implementations. So it'll be mobile first. And then, session keys, like we talked about, 2FA, all these things, but ultimately still being non-custodial, as every good app in crypto should be. So those are some of the things that these accounts enable. And let's just give an example. So I'll just walk through one specific example. Again, you can imagine that you could do theoretically anything, and because we're building on this like modular hook infrastructure, as the possibilities within DeFi continue to evolve, the protocol is kind of extensible and future-proof, such that it should be able to anything that gets developed, you should be able to do on Superform in the future. And we can just like build it in through this hook that is just like, appended to the transaction. So we can do anything, and we can do anything in one transaction. But we're going to specifically look at this case where I want to, I have assets on chain A and assets on chain B, and I want to deposit into some vault, some earning opportunity on chain C. So just to use some terminology from the rest of the presentation, we have the super bundler that's going to take the user's intent, and the intent is just simply, what do I want to do? And then, ideally, not initially, but we can get to the point where an intent can just be, I type it out. Like some apps are already starting to do this. Like I just type literally, like natural language. I want to send this asset on this chain to this asset or this protocol on this chain, and then it just does it, right? But initially, to specify your intent, you'll have some interface that you have to go. You have to select the asset, select the thing, so it's more not actually saying what you want to do, but that's your intent. It's what do I want to do? And it's going to be this bundle of hooks. And a hook could be a swap hook and a bridge hook and a deposit hook. These are just like simple actions that build this transaction bundle. And each of those things is a user op. And then the user op is processed through the canonical entry point contract on the chain. And it can be any chain that Superform supports. So to break it down a little further, so here, let's say we wanted to do these 3 user ops. Super bundler this intent, which is I want to bridge these 2 assets to from these 2 chains to the 3rd chain and make a deposit. So on chain A, we have one single hook. That's a bridge hook. So I say I have USDC on chain A, I have USDT on chain B, and I want to deposit into a Morpho USDC vault on chain C. Okay, so because I have USDC on chain A, I don't have to swap. I'll just bridge. So one bridge hook to send from chain A to chain C, my USDC. On chain B, I have the wrong asset, so I have to do 2 hooks. One's a swap to USDC, and then the bridge, chain C. And then once it's on chain C, I can do a bunch of things with it. So I've got all my USDC from those 2 chains on chain C, and now there's this user op is going to have 3 hooks. And this is going to be, we can deposit into the vault. We get some vault share back for depositing. I can now do something with those vault shares. I can maybe stake those, and then I'm going to mint a superposition. So this is some like receipt token to represent all these actions that I've done, and I can mint this on whatever chain. It's somewhat arbitrary. And so importantly here, so there's one signature that represents all of these user ops collected at the start. So there's one single signature to execute this entire bundle of user ops across multiple chains. But importantly, the user op on chain C is only executed after the successful completion of operations on chain A and chain B. And then in a diagram form, again, using a little bit of what we were looking at before, this is what it kind of looks like. So on the Superform app in my embedded wallet, I'm going to specify my intent, which is broken up into these 3 user ops with 1, 2, and 3 hooks in the user ops. And then these user ops get sent to the super bundler. Then the super bundler is going to send those to the chain, on chain. And then these things execute on the chain. They are, interacting again with the entry point contract that's like doing the execution. But you can kind of see what's going to happen here. So again, you have chain A and then there's a Superform account on each chain, right? You have one instance of your Superform account, which is your smart contract account, on each chain with the same address. And you see on chain A, there's the bridge. Chain B will be the swap, and then the bridge. And once it gets to chain C, it does the 3 actions we said, which are deposit, stake, and mint. So that's what that looks like. My question to Yoni would be going back to what we were talking about before, when we said that there was like kind of one user op per transaction. So how is it that so this is to do with maybe our super bundler architecture. Again, I'm not super familiar exactly with how this works, so I want to figure it out myself. Obviously, I would talk to one of my devs to really figure it out, but just for us here, how can I execute all 3 of these user ops that interact with 3 different chains in one single transaction? Microphone.
What I was saying is that it depends on the state transitions on that single chain, right? You can't, you cannot do things on chain C like the deposit, stake, mint until, you know, I guess you're kind of loaning it out, right? If you're not waiting for like the bridge to finalize, you're kind of saying like, all right, well, you know, you're gonna have stuff there, so we'll like accrue things for you.
We're using like a cross, for example, which is like, you know, it's like solvers. So basically, yeah, in a way there is like this borrowing concept, but these bridges are very fast, right? So
that all makes sense. I'm just saying if you're on like say a single chain like chain C, you're not able to do things without, you know, loaning that out unless there's like an actual balance change. You know what I mean? That was my point.
I see. Yeah.
But like cross chain, yes, but because you're assuming that like, all right, those are, you know, those state transitions happen, and if they didn't, you know, you're not out that much, right?
Right. So it's like trust assumptions at like the
it
bridge
depends on
level,
how your bridge
right?
works, but like you can't use say you've never interacted on chain C before.
Yeah.
And then you're doing something where you're swapping and you know, and bridging in the same. Well, bridging is like, all right, maybe you're just sending it to some bridge contract like deposit, right? If you've never interacted with it before, like how do we, you know, unlock those funds for you, you know, to be able to run the user op 3? You know what I mean? So it's like we're kind of assuming that you will have funds to be able to deposit and stake, and it'll be so much. So for the sake of, I don't know, UX, yeah, you can run with that, but I'm saying it actually needs, and it doesn't disagree with what you wrote on the previous slide, that like the user op on chain C is only executed later, so like it's not all in the same block.
Right. Yeah.
So maybe it was unclear. Let's revise it to say that like this can't all happen within like one transaction.
Sure. Yeah. The actual execution is not atomic, but we can set the stage for all this stuff in one. I mean, is it even a transaction? I guess. Yeah.
It's mostly like the chain B. The things happening on chain B, that is like fitting more actions into a user op. Very clever.
Yeah. So this is what we were talking about, right? Like this is why I brought it up. Like, so we have a swap and a bridge in one user op. So is that like, I'm not sure exactly how that part works, because it would seem those are like 2 separate things. But
I think if you looked into it, there is like an assumption that, you know, we can, you know, maybe there's a, what do we call it? Like an optimistic assumption that we can like swap into that token and then send it to the bridge, and the bridge understands it and everything like that. Like they've simulated this, but I'm saying like that is like operating on a little bit of faith that those things can happen.
Yeah, it'd probably have to be simulated, right? Like you couldn't send the user op unless like somehow you're validating beforehand that it would actually work, right?
Yeah, there's a reason why the like not the spec, but the reference implementation doesn't do that. You know.
Yeah.
But yeah, you can do cool things with UX if you're trusting that you know you can run those things and it's not going to cost you. No one's going to defraud or do something squirrely with it.
Yeah.
And on other chains, like okay, you're respecting the dependency, and then things happening on other chains in parallel. Absolutely, you can do all that, but it's not just atomic. It's more like I don't know. They're dependent on
there's
other
a sequential.
conditions. Yeah, there's
Yeah.
sequential.
But
Exactly, it's a
specifically
different
in a order.
property that it's trying to
For
preserve.
sure. And then, like you said, that is kind of like mentioned down
Yeah,
here,
yeah.
right? So obviously things have to happen in a certain order. That's just
Yeah.
like logical. But we can, the important thing is we can like in one, not even one transaction, with one signature, with my Google account, I can just say, hey, I want to do all this stuff, and then it just kind of does it. That's the magic. You had something?
It's delegating it elsewhere.
I was gonna ask something related. Like, I assume that the protocols on chain BNC and the bridge partner, it all has to be like pre-integrated into the super bundler. Like,
Yeah, it would be somehow if not like specified in the user op, like the super bundler, when it's bundling these 3 user ops, it's gonna say, okay, for each of these 2 bridge hooks, we're gonna use, across for this one and Stargate for this one, right? I guess that has to be predetermined.
yeah, you can't like interact with the random protocol that's not compatible with this system.
No, so that's why actually we're like right now, like that's a discussion we just had, like what bridges are we going to use, and we can't just say any random bridge, right? Like there has to be this was very specific like qualifications for these bridges, which is why they have to be like very fast. So that's why like Across and Stargate are like 2 of the ones, the like primary ones we're looking at, maybe D-Bridge as well.
And like I get what you're saying, like the user's intent is like done with one signature, and then there's like sequential transactions that does the rest of the stuff, but how the system deals with like transactions reverting, like let's say I successfully bridge, but once I get to chain C, there's like a deposit cap on the protocol I want to deposit into, and there's some maybe simulation involved, or
Yeah, even if you simulated it, because it's like asynchronous, like something could happen, but then that's also baked in. I mean, we deal with that now, even like in the V1 version, like still by the time you get to chain B, there can be something that reverts, and then you just have to have some mechanism to just refund the user on the chain, whatever chain they executed from or whatever. So yeah, there's some mechanism in the event that something reverts, it'll get refunded at some step of the process on whichever chain makes the most sense. I'm sure that the smart guys are figuring that out.
and the auditors must like play with this because
Yeah,
it can
for
be
sure.
like attack vector.
I think it'd be a fascinating thing to like audit and be looking at right now, because they have some cool shit going on for sure. Yeah.
About the signature thing, so you're saying like how can we do all ops one signature? So like in the example that I showed, I signed with my Google account,
Yeah.
right? And that doesn't do anything on chain. So one trivial implementation is like if this was my intent, I could sign a message with my EOA that says I want to do user op, I want to bridge A to C and then B to C, and then I signed that like those 5-6 steps in a message, and like that's a message, and then that signed message is actually passed into each user op. Right,
I
and then
see.
it's like for the Superform account, so like open up that message and say, okay, actually, what you actually want to do is actually impart of this message, right? So like because signatures can be anything, it's kind of up to your creativity to like figure out how you want to sign it, because
Yeah.
you're not signing transactions, you're
Yeah,
signing
I
operations.
think that was
you're
that was the
signing
confusion
type
there.
data,
Yeah.
And
So it's
also
not
transferring, like I assume.
Transferring what?
Like I assume you're also transferring funds, signing the withdrawal or
Right. Yeah.
deposit,
Yeah. So
right?
like maybe on step 4 is
Yeah.
like a withdrawal, like because ultimately the on-chain signature is from the bundler, from Super Bundler EOA.
Yes.
The user is just kind of like
You're
approving.
assigned type data some like
Right, so that could be
standard format.
whatever you want. Like maybe Superform has a special way of like signing it, so that because again, this is your Superform account. It does the signature doesn't need to work anywhere else.
Yeah.
It just needs to work for you guys. So you can, because maybe there's a secret that you guys pass across everything that like you guys have somehow baked in, right? So that's how you can kind of like maybe the trivial thing is like your Superform account says, hey, if Super Bundler says you can do it, then you can do it, and that's a security, and right, and like maybe all the trust is there, and it's like not super secure, but again, it's something you guys can do because it's like you guys have it super tightly integrated. So this idea of like one signature, infinite transactions could just be somewhat hand waving at like how it's actually done. But I mean, like in theory, like the example of like, hey, just sign all 6 steps in a single message and pass it around. That could be like one trivial implementation of it.
Anyway.
Do you know how many? Well, I guess it depends on these chains and some other factors of the protocols. But do you know how many transactions would actually happen under the hood?
For this to happen?
Yeah.
Oh, like I would have to like highly estimate many.
Okay.
A lot would be going on. I think. Yeah.
So I accept that I'm wrong. That there's not always one-to-one between that, depending on what's going on. But
yeah.
But I'm still sticking firm with like my sequential and like you're kind of optimistically assuming that you can
definitely
from
I think the optimism is happening mostly at like the bridge solver level would be my guess. Anyway, the white paper I think is coming out next month, so we'll all figure it out then. Anyway, I wanted to share that. I'm trying to understand it better myself, because I have to get ready to like explain this shit to the Discord plebs. So anyway, any other questions, or that's basically Q&A, but we've had a lot of questions, so it's they already started the show upstairs. Maybe we're all good here. Yeah. All right. Thanks, everybody. Thank you, Andrew. This was awesome.
Thank you,
that's it. That's the show.
Thank you guys.
Any questions? Any Q&A? No? All right.
How
Yeah.
does this work? TXOs.